All right, you guys. So we are now going to move into adding rational expressions. Okay. So we're going to start off simple and just know that we're going to be doing this for a couple of days. So this is not something that if you don't understand it right away today, don't think that tomorrow is going to be a completely new topic. No, we're going to sit on this topic for a couple of days because um, it's pretty important, and we can't solve them if we add in an equal sign unless we can complete all the steps correctly. All right, so we're going to start off with just some simple ones today that have some simple fixes to give them a common denominator. Because remember, if you add fractions, you have to have a common denominator. Well, 2x and 6x are not common. They are different. So we have to make adjustments. All right, so here's where, if you need to go back and review, you can go to Khan Academy, you can go to Google and look up, adding fractions with unlike denominators to give yourself a review. But all right, so if I look at 2x and I look at 6x, okay, I know that they each have an x, so that's good. They have that in common. And then I know that 2, if I multiply it by 3, it'll equal 6. Now, when you can't just go and say, "Oh, I'm going to just multiply this by 3." Okay? Because you have to keep a fraction, you have to keep it equivalent. So you have to multiply it by 1 or a version of 1. So I have to multiply by 3 over 3. Okay. And when I take 3 over 3 and I multiply right here, okay, so I'm going to multiply the numerator and the denominator by 3. So 3 times 3 gives me 9. 3 times 2x gives me 6x. And if I bring down plus 5 over 6x, notice I have like denominators now, okay? Which means I can add. Now, when you add fractions, you only add their numerators. So 9 plus 5, that is 14 over 6x. Notice I did not add the denominators. Okay. It remains 6x. Okay. All right. So now this is my answer, but now it is my responsibility to simplify. So this is where we're going to take in all the techniques we've been working on in this unit. Okay. And we're going to simplify. So I can divide the top and the bottom by 2. So 14 divided by 2 is 7. And 6 divided by 2 is 3x. And this is my final answer. Okay? All right. So moving on to the next example. So I have 7 over 9x plus 1 over 2x. All right. I would like to add those, and they need to have a common denominator. Well, they each have an x. Okay. There's not, I can't take 2. Like if I look at the smaller numerical value, 2, I can't multiply 2 by anything and it'll equal 9. Okay. So I'm going to have to multiply 2 by something and 9 by something. Okay. We want to keep this as small as possible. Okay. So I'm looking at their least common multiple. Now you can, okay, there's a feature on your calculator. So if you go over to math, you go over to number, you go down to 8. There's your least common multiple of 9 comma 2 is 18. Okay, so I need to multiply 9 by something to get 18, and multiply 2 by something to get 18. So now it's going to look different for each fraction. So I'm going to multiply this one by 2, so the top and the bottom by 2. And I'm going to multiply this one, top and the bottom, by 9. Okay, so notice I did not multiply by the exact same thing. But here's what happens. 2 times 7, 14. 2 times 9x, 18x, plus 1 times 9, 9. 2x times 9, 18x. So notice my denominators now match. Okay. All right. And then just like the last problem, in order to add these, I'll add the numerators only. Well, 14 plus 9, that is 23 over 18x. All right, and 23 over 18, and again, if you've got your calculator, you're not sure about 23 over 18, whether or not it simplifies, math enter, enter, okay, you get the same answer. So this is my final answer. Okay? All right. I will come back with a second video, and that's it for now. I'll come back with a second video like I just said. Thanks, guys.